Hello everyone and welcome to Unit 7, which is on quadrilaterals. We are doing day 1 today, which is on polygons. So, the basics of polygons. A polygon is a 3 or more sided shape, like so. And it is formed by a non-collinear, two L's in collinear, segments. So all 3 segments are non-collinear, meaning like you can't have a side here and a side here. It doesn't work like that. That's not 2 sides, that's just one big side. Each side is going to intersect at an endpoint. Each side intersects at endpoint. So here are all my sides, and you can see that they all only touch at the endpoints of those sides, which are at all of the corners. So down here we are going to identify whether or not these shapes are polygons. Number 1, yes, it is a polygon. All of the sides intersect at the corners. Number 2, yes, all of the sides intersect at the corners. Number 3, yes, all of the side intersects at the corners. Number 4, no, our sides do not intersect here. And we also have a curved side, but we'll get to that later. Number 5, no. We can't have collinear sides. You can see that this side is not collinear with that side, or it is collinear with that side. They intersect right here and not at the endpoints. They have to only cross at the endpoints. Okay. Naming the polygons. Each polygon has a separate name. You are most familiar with triangles at this point because we've done a lot with triangles. A triangle is a 3-sided polygon. A 4-sided polygon we call a quadrilateral. 5-sided pentagon, 6-sided hexagon, 7-sided heptagon, 8-sided octagon, 9-sided nonagon, 10-sided decagon, 11-sided hendecagon, 12-sided dodecagon, and we can go on, but if we get more than 12 sides, we'll probably just say like 20gon or 30gon, depending on however many sides it has. But you are going to want to memorize these. Get really familiar with those names because they are going to come up a lot of like how many sides does an octagon have, and you have to know that an octagon has 8 sides based on the name. Next we have convex and concave. Convex means it has no dips, and I'll explain what that means in a second. And concave means it has a dip or more than one. Could have more than one dip. Here's an example of a convex polygon. You can see that all of the sides intersect at the corners, and all of the sides kind of point out. They're all kind of pointing out this way, out of the polygon. Whereas in the concave polygon, we have all of our sides here, but then we have this one little corner that points inside. So all of these angles point out, like so. But this one points in. If any of them point in, then that is concave. It has a little dip. This is our little dip right here. It dips into the polygon. So, number 1 and number 2 down here, we're trying to just decide if it's going to be convex or concave. Number 1 is concave. We can tell because it has these little dips. Dip, dip. Number 2 is convex. No dips. Then we have regular polygons. Regular polygons are going to be equiangular and equilateral. I've spelled equiangular wrong. Okay. Equiangular means all angles are equal. And equilateral means all sides are equal. That's the same definitions as they were with triangles. Now we're just applying it to shapes with more sides. All the same things though. So number 1 through 3, we're just deciding if they are regular or not. Number 1, we would say it is not regular. You can see that maybe all the sides are the same, but this angle is definitely way bigger than that angle. So not equiangular. Number 2, this one would be a regular polygon. You can see all of our sides are marked as congruent and all of our angles are marked as congruent. Number 3, this would be a not regular. Not all angles the same. You can see that we have 2 right angles at the bottom, but none of these other 3 angles are right angles, therefore not regular. Next, we have the interior angles of polygons theorem. So interior angles are the angles inside the polygons. So like this, 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 and this are all called interior angles. So basically, the number of degrees in a polygon, so when you add up all the angles, the amount that they all add up to is going to be equal to 180 times n minus 2, where n is the number of sides that the polygon has. So if I were given a polygon with 20 sides, I could put 20 in for n and find out how many degrees all of the angles are going to add up to be. For quadrilaterals, we already know that all of them will add up to 360 degrees. Always. For all 4-sided polygons. Using that fact, we can solve for x and figure out the measure of these angles. So if I'm looking at this quadrilateral, I'm going to add up all of my angles. X plus 2x plus 80 plus 70. And it should all add up to 360 because it is a quadrilateral. It has 4 sides, so it should equal 360 when I add up all of my angles. We'll add these 2 together, so we'll get 3x, and we'll add these 2 together, and we'll get 150, and that'll be equal to 360. Then I'll subtract that 150 over, and I get, and I'm going to move kind of up here, 3x is equal to 210. Divide by 3 here, and I get x is equal to 70. Cool. Same goes for this example. Add up all 4 of my angles. 4x minus 13 plus 7x minus 8 plus 5x plus 5 plus 5x minus 2. And it should all add up to 360 because that's a quadrilateral, and quadrilaterals will always add up to 360 when you add up all the angles. Next thing I'm going to do is I'm going to combine my like terms. So I'm going to combine all of the terms with an x. So 4x plus 4x plus 7x plus 5x plus 5x, that'll be 21x when I add all those up. Then we'll do all of the ones without x, so minus 13, minus 8, plus 5, and minus 2. Add all those up, and I get minus 18, still all equal to 360. We'll add over that 18, and we get 21x is equal to 378. Then we'll divide by 21 on both sides to get that x alone, and we end up with x is equal to 18. Since we were just asked to find x, we're done once we do that. And that is it for day 1. We'll see you all back for day 2. Bye.